Welcome back to yet another video on this GCSE 5-a-day maths series. So this is 12th of Jan 2026 and we're doing grade 8 and grade 9 topics. Grade 8, grade 9. First question is a simultaneous equations question, and it's a bit different because we notice that you've got an xy term. The x and the y's are not separated. So what's nice about this question is you've got the x as a subject for you, so they've done that nice bit for us. So what we're going to do is we're going to take that x and we're going to plug in that x into equation number 2. So that means this would now become 3 lots of, in place of x, we get to write 3y plus 6, and y remains as y is equal to 24 minus, in place of x, we're going to write 3y plus 6. So we've got that bit. And obviously, we could expand the brackets now. So that'll be 9y plus 18 lots of y equals 24. Take away 3y, take away 6. So that'll be 9y squared plus 18y is equal to 18 take away 3y. Looks like a nice, neat quadratic equation. So if we try to collect all the terms, so we're going to kick the 18 onto the other side and the 3y as well onto the other side. We get 9y squared plus 3y plus 18. That becomes plus 21y. And then minus 18 is equal to 0. Straight away, we can divide by 3, so to make life easier. So let's do 3y squared plus 7y minus 6 is equal to 0. I don't think we can do anything more, so we're going to have to try to factorize this. So, what we can do is, yeah, obviously I'm going to multiply the 3 onto that last term. So that will be y squared plus 7y minus 18 is equal to 0. I can factorize that as y plus 9y minus 2 is equal to 0. And then obviously because I did the multiplication by 3, now I'm going to have to do division by 3, so divide by 3, divide by 3, and this now becomes y plus 3 and then 3y minus 2 is equal to 0, because obviously the 3 moves over to the other side. And now we get the two factors, which means we could now figure out that y is equal to minus 3 or y is equal to, so how do I get the next one? I can say 3y minus 2 is equal to 0, which means y is equal to 2/3. So I've got the two values for y, which means I could go back and then plug in those values to figure out what are the values for x. So the first value was minus 3. So if I plug in minus 3, we get x is equal to 3 times minus 3, that would be minus 9 plus 6, which should give us minus 3. So for y is equal to minus 3, x is equal to minus 3. That's our first pair of solution. Or if I plug in y as 2/3, so if I plug in y as 2/3, 3 times 2/3, that would be 2, and then 2 plus 6 would give me 8. So now we have x is equal to 8. That is our second pair of solutions. So that's how we do this simultaneous equation. So the first step was plugging in y, making a quadratic, solving that quadratic, figuring out what is y, and then finally bringing back the y to figure out what is x. Nice little question there. Next one is completing the squares. So x squared plus 8x plus 7. So obviously x squared plus 8x. That's a very straightforward question. Nothing tricky there. So x squared plus 8x plus 17. So obviously x, take half of that, which is x plus 4, square it, and then take the number, square it, and then subtract it on the outside. So that would be 4 squared, which is 16. Subtract 16 on the outside, but you still have a 17 lurking behind, or lurking still in the background. Now we just tidy that up. So that will be x plus 4 squared, and then plus 1. So yeah, that will be that. Now find the coordinates of the turning point. So if you want to find the coordinates of the turning point, remember that's one good thing about using the completing the square method form, that it helps you to figure out what the turning point is. Only thing that you have to remember is the y coordinate remains as the y coordinate. So that number, sorry, the number outside remains as the y coordinate, which is 1. And the number that is stuck with your x, you need to flip that to get your x coordinate, which is minus 4. So the coordinates of the turning point would be minus 4, 1, which you get from the completed squared form. Moving on to the next question. This one says, find what is BC. That looks very difficult. Obviously, this looks like a sine rule, cosine rule question, so it is advanced trigonometry, but we don't have any triangles in this, so let's make a triangle first. That's the first thing that is coming to my mind. It looks like a 5-marker question, definitely. So what I'm going to do is maybe I'll draw a new triangle here, the one that I have constructed. So I've got A, I've got D, and I've got C. This is 14, this is 7, and I've got the angle here that is 70. So if I look at this, this is like a sandwich angle or a trapped angles, because the angle is trapped in between these two sides. So if it is a trapped angle or a sandwich angle, we know it is cosine rule. When you're going to do cosine rule, first let's write cosine rule. So I have a squared plus b squared, leave a bit of gap, and then write c squared. Cosine rule would be minus 2 lots of, so we bring in that extra term, minus 2 lots of AB, and then cosine of the angle, which is C. So you've got to remember the cosine angle matches with the side here. And then these two matches with the two numbers there. So that is the technique of writing the cosine rule formula. Works like Pythagoras, structure is like Pythagoras, but you have this extra term here. Now the next thing that we're going to do is I'm going to rename the sides, because this is my triangle. I can rename it my way. Because of the formula that I have memorized, or I tend to use, my angle, I prefer it always to be C. So that means this would be my lowercase c, and I'm going to call this one as A, this one as B. So this would be lowercase a, and this one would be lowercase b. Now I can plug this into the formula. So a squared becomes 14 squared, b squared becomes 7 squared, minus 2 lots of ab becomes 14 times 7, and then cosine of c would be cosine of 70, and that is equal to c squared. So let's go to our calculator, let's plug this in, and then maybe we'll figure out what c squared is. So 14 squared, 7 squared. Okay, so let's do 14 squared plus 7 squared minus 2 lots of 14 times 7 times cosine of the angle 70. Oh, I think I am in radians. Oops, oops, oops. Okay, so you have to be careful with this in your exam as well. Let me see if I am in radians. So, angle unit. Yeah, we need to change this to degrees. So before you go to your test, make sure that this is in degrees. Okay, now I need to come back. How do I go back? Yeah, go back, go back, go back. Now, if you look at your calculator, if there is a tiny d at your top, that means it says degrees. You're fine. Okay. So the answer is 177.96. I'll just write that down so that I might get a method mark. 177.96. And then finally, we're gonna say square root of my answer button. That will be 13.34. So this right here is 13.3. Okay, maybe we'll use one more, 13.34. Yeah, maybe towards the end of your answer you can use 3 significant figures. All the way throughout your workings, it's good to use 4 significant figures. So 13.34 is this side here. Okay, so that part is okay, but it still doesn't help us to get to the question mark or the unknown side that we are looking for. I've got 2 sides, so if I draw the other triangle, which is so if I draw the green triangle here now, that would look something like, so this is the unknown side I'm looking for. I know this side is 8, I know this side is 13.4, 13.34, my bad. Maybe if I knew this angle, then I could have done the trapped angle cosine rule thing and I could have found the side opposite to that, but I don't know that angle, do I? So then the obvious question is there anything I can do to work out what that angle is? I know the full angle is 150. Maybe if I knew what this was, I could then work out what is the other, because all I have to do is just take that away from 150. So to do that, I come back again to my old triangle. So I am looking for the unknown angle here. I know the side that is opposite to it. I also know an angle side pair. So if you have 2 pairs of angle side, that tells you you're going to use your sine rule. Okay, so in your sine rule, you ask yourself, are you finding an angle or are you finding the side? I am finding an angle, so I am going to write the angle part first. So that's sine of the angle x, which I'm looking for. Opposite to that is the side 14. So sine x over 14 is equal to, look at the other pair of angle side you've got, sine of the angle 70 over the side that is opposite to that, that will be 13.34. Now what you're going to do is you're going to cross multiply this and you would find what is the angle x. So I've got sine 70 times 14 over 13.34. So let's go back to our calculator. Let's clear this. So that's sine 70 times 14. I've got to divide that by 13.34. If I do that, I get 0.968, but that's not what we want. That's not what we want. We want the angle. So we're going to press shift and sine inverse and the answer. And then that should give us 80.46. Okay. So the angle, excuse me. So the angle, don't know what that is. We're going to find x is equal to 80.46 degrees. So sine x, maybe I can write one more step here. Sine 70 over 13.34. Multiply that by, oops. Sorry guys. Okay, I should try zoom out. Okay, yeah, that's 14. So I've found out that angle, which is 80.46. Now that means I can find the remaining piece or the rest of that piece. So I know this is, the full thing is 150, okay, the angle that we've got here. And this tiny piece is 80.46. So the rest of that should be, excuse me, 150, take away 80.46. Gotta go back to the calculator again. So 150 take away 80.46, and that is, change that to decimal, 69.54. So the angle that we were interested in is 69.54, which is this little angle here, 69.54. That means I've got another triangle in which there is a trapped angle, and I can use a cosine rule again. So let me write, I think I've written the formula at the top, haven't I? Yeah. So all I have to do now is rewrite A, B, and C. Now I always prefer the angle to be C, and I'm going to call this A, this as B, which means the side opposite to that, this would be A, side opposite to this, that would be B, and C is what I'm looking for. So if we write the formula again, this would be A squared, which is 13.34 squared, plus B squared, which is 8 squared, minus, excuse me, 2 lots of 13.34 times 8 cosine of the angle 69.54, and that would be equal to C squared. So let's do that. 13.34 and 8. This is taking a while, isn't it? 13.34, square that, and 8 squared, take away 2 lots of 13.34 times 8, and that gives me my C squared. Oh, no, 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 I need to go back, because I forgot the cosine. That's why, because I was thinking, yeah, that looks a very small number. You need to have a bit of an intuition to know if you've done that wrong, because obviously 28 does look really, really small. So cosine 69.54. Okay, so cosine 69.54, and if you plug that in, you would get 167.34, but that is C squared. We need square root of that. So square root of that is 12.93. Oops, pressed the wrong button. So the unknown side, maybe I could write this as in a single line. Once you've done this, to get your final answer, just do this, square root of all of this. That gives you, oh my bad, what was that number again? 13.3, 12.93. Okay, so the answer that we're looking for, 12.93. If you want to do that to 3 significant figures, that'll be 12.9 centimeters. So took us a long while, uses both cosine rule and sine rule question, grade 9 question, 5-marker question. Do practice these ones too, so that when you see them, you kind of know what you are getting into. Here's another one. Below is a speed time graph. Oh, looks a bit tricky. Work out an estimate of the acceleration and the distance. Okay, this requires us a bit of physics, but it's okay. It's okay. We'll get there. Right. Okay, so the first thing that we need to remember is of a miniature locomotive. So the first thing that I want you to remember, when you have a speed time graph, so you have speed time graph, the gradient, okay, the gradient of a speed time graph is acceleration. Okay, that's the first thing that I want you to remember. Then, if you have a distance time graph, and if you look for your gradient, that gradient is your speed. Okay, so what do we have to work out? Work out an estimate for the distance. Okay, don't worry about the distance. We need an estimate for the acceleration at 20 seconds. So we are going to figure out the gradient at 20 seconds. For that, you're going to have to zoom in, go to 20. We're going to make a nice little tangent at that point. So you might want to grab your ruler here. Make sure it's tiny. You don't want to make it too long. So the point that you're looking to is at 20 seconds. So let's first figure out where. Okay, so first identify where is the point. So this is the point that you're looking for. You're going to make a nice little tangent there, not too long and not too short. So let me see if I can do. It didn't work. Okay, let me see if I can do. I was hoping this would become a straight line if I hold it long enough. No, it didn't. Okay, didn't become a straight line. Okay, so maybe if I reduce the width, maybe, yeah, maybe if I reduce the thickness, let's see. Okay, so I'm gonna start from here. That's not a good tangent line if I'm being honest. Yeah, maybe I'll do this. It should go through the line. Yeah, that looks good enough for me. So you don't want to make it too short. You don't want to make it too long. Make sure it is kind of fitting in to the line that you're drawing. Okay, so now what we're going to do is I'm going to take the 2 points that I need to figure out the rise over run. So this looks like 3.4 and the bottom end. Now you can make it slightly shorter if you wish to. I just made this. It is only an estimate, so you will still get your marks for that. And then this is 2.6. Yeah. So using that, I can figure out the rise. So from 2.6, I have gone up to 3.4. So 3.4 take away 2.6 gives me the rise, which is 0.8. Now, I need to work out the run. So the run, if I drop this line all the way down, that's looking like, so this is 10. 4, no, that's 1, 2, 3, so that should be 16. Drop the next line. If I drop the line, that's 2 lines away from 20, so that's 24. So 16 through 24, so that's 24. Take away 16. Your run is 8. Oh, that's good. That's nice. I've done a good job there. So the rise is 0.8, the run is just an 8. If you do that, you get rise over run, which is 0.1, and that is your acceleration. So acceleration is the gradient of a speed time graph, and we know how to find the gradient. Don't make it too long. So what I don't want you to do is, if you make it too long, don't make it too long in such a way that it kind of goes like this, or you don't want it to deviate. Maybe if I had a ruler, I could have shown you what I'm trying not to do. If I draw something like this, that would be incorrect. Okay, if I am making it like this, that would also be incorrect. So don't make it too long in such a way that it kind of sticks out of the graph. Try to keep it long enough in such a way that it's easy for you to calculate, but make sure your graph doesn't spill out of the original graph. The better you put that, the better you try to fit it into your curve, the better would be your answer. Okay, last one. Work out an estimate for the distance traveled during the entire journey. Oh my god. Okay, so next idea that I want you to remember, if you have a speed time graph, area under this graph would be the distance. Okay, so whenever you have a speed time graph or a velocity time graph, the area under that graph would be equal to the distance. But now the question is, how do I find the area of this curve? And for that, unfortunately, we don't have a choice, but we're going to have to split this up into segments, and we're going to have to find areas like that. Now for this, we're going to bring in something called as the trapezium rule or the trapezium technique. So when I look at this, I can see I can make nice little strips of 20 each. I could have done 10, but that's too much work. You know I'm lazy, so I am going to do... it says estimate, so I think I'll be fine. Okay. So what I've done here is I've kind of split them into 5. Now sometimes the question will say into 4 strips of equal width. If they said 4 strips, then you would have done 100 over 4, which is 25, which means you're going to have to split them up after every 25 seconds. For this one, they haven't really mentioned anything, so I'm just going to go with this. Now what we're going to do is we're going to assume that the first shape here, now I wish my... Does it become a line? Oh, it became a line. Okay. So what I'm going to do is I'm going to draw lines. Did it become a line? No, it didn't. Okay, it didn't become a line. We're going to draw lines. Yeah, this one became a line. To kind of change these things into trapeziums. So we're going to find the areas of the trapeziums. Oh, I wish I could figure out how to do this. Okay. Come on, come on, come on. Yeah. Okay, got that one. And then finally, we're going to do the triangle. Triangle, please, come on. No, then. Okay, but I hope you get the idea there. It's just a triangle. So I'm just going to, even if this doesn't work, I'm just going to do this with a free hand. Oh, yeah, there you go. Right, so the easy part is finding, I think, the area of those triangles. So this triangle, it looks nearly good as the 3. So that means the height of this triangle is 3. The base of this triangle is 20. So that means for this part, I could do half of 20 times 3. Okay, so that's 10 times. So the area here would be 30. For the triangle at the end, I think it was 2.5. Obviously, they'll give you nice numbers, I think. If they are nice, they shouldn't be giving you weird numbers. So that's 2.5. So I know the height is 2.5. And the base is not 100. It's only from 80 till 100. That means the base is still 20. So for the second rectangle, again, we're going to do half of base is 20 times 2.5. So that's 10 times 2.5, which is 25. So I've got the first 2 triangles done. Now for the trapezium in the middle, I know this is, and let's see, what is this? This is 4.4. Okay, so this is 4.4. And then I'm going to need one right here. That looks like 4.3. And this one was 2.5, wasn't it? Will that become a straight line? Yeah. And this one was 2.5. So if I look at that first trapezium that I have to actually figure out the area for, I've got the base, which is 20. And then I've got the smaller height, which is 3, and the longer height, which is 4.4. So usually for a triangle, sorry, for a rectangle, I would have done base times height. But because I have two heights here, I'm going to take the middle value of both the heights. So I'm going to do 3 plus 4.4 and divide that by 2. That will be the average of the two heights times that with the base, which is 20. So 3 plus 4 over 4, sorry, 3 plus 4.4, divide that by 2. So let's do that. 3 plus 4.4 is that. Divide that by 2, and that's 37. 10, and then times your answer by 20, we get 74. So the first rectangle here, sorry, trapezium here would be 74. Now for the second trapezium that we've got, oops. So the second trapezium that we've got, the taller height, the higher one is 4.4. So this is 4.4. The base is 20. This is 4.3, which is slightly less. So the average, or the average height, is 4.4 plus 4.3, divide that by 2. So I'm trying to find the middle of those two numbers. I shouldn't have done that. And then multiply that with 20, which is the base. So that's 4.4 and 4.3. Obviously the middle is 4.35. So 4.35 times that by 20, which gives us 87. So this one would be 87. And for that last trapezium, the taller height is 4.3, the smaller one is 2.5. So we're going to find the middle of 2.5 and 4.3. So what we're doing is 4.3 is the bigger value, 2.5 is a smaller value. Find the middle of these two, multiply that with the base, which is 20. So 4.3 plus 2.5. Now, please don't make the mistake of pressing the division there, because that wouldn't be right, because that means you're dividing the 2.5. We want to divide the entire thing. So actually get the answer, then do the division there. I was about to do that, but then I realized, oh, that's not really right. So we do that, we get 17.5, and then times that with 20. So that is 68. So if I go back, this would be 68, and now all I have to do is add these numbers together. So that's 30 plus 74, 87. 30, 74, 87. Let me see if I can remember them. 30, 74, 87. 30 plus 74 plus 87. They say if you actually say it, you will try to, your short-term memory might lose. Yeah, 30, 74, 87. And then we're doing 68 and 20. So 68 and 20. 68 and 20. So the final answer is 279. So the final answer would be 279. Was it, or was it 89? 79. Now the next question is, would this answer be an underestimate or a lower estimate? So the logic, oops. So what, oh my God. Sorry. Yeah, I know that part. It's something wrong with the software. Doesn't go. Right, now the question is this an underestimate or a lower estimate? Now it is an underestimate because if you look at the area that we have done using our estimation, this area is kind of within the red polygon that we have drawn. And if I shade the area that we have actually figured out, you can kind of see there is still a bit of area that is left on the outside, which is, if I were to show that, if I have to be more precise, this, maybe don't use that color. If you notice this area, and if you can zoom in, this area, you will find bits of pieces that we've actually left out while we try to find the area. So is this an underestimate? Yes. So the reason is the trapeziums are below, or I wouldn't say below, you can say are under the curve. Under the curve. So if the trapezium were above the curve, then it would have been an overestimate, but because the trapeziums are under the curve, you still have area which is left out of, or which we still haven't counted for. So the trapeziums are under the curve makes this an underestimate. So yeah, it was a long video, but I hope this made some sense into some of those long questions. And I'll see you in another video. Take care. Bye bye.